In the early morning darkness of June 13th, 1944, exactly 1 week after Allied forces had stormed the beaches of Normandy, the people of London were jolted awake by a sound they had never heard before. It was not the familiar drone of German bomber engines. It was not the wail of air raid sirens. It was something altogether more sinister, a strange, mechanical buzzing, like an enormous angry insect racing across the sky at impossible speed. Royal Observer Corps spotters in Kent watched in disbelief as a small, dart-like aircraft with flames shooting from its tail streaked overhead. Then, without warning, the buzzing stopped. In the terrifying silence that followed, the object plummeted from the sky and exploded in Bethnal Green, destroying everything within its reach. 6 people perished instantly. 200 were left without homes. And Britain found itself facing a new kind of terror, one that would push its scientists to their absolute limits and force them to confront disturbing truths about the nature of modern warfare. This is the story of the V-1 flying bomb, Hitler's first vengeance weapon, and the remarkable British scientists who raced against time to understand this deadly device. What they discovered when they finally got their hands on one would change not only the course of the war, but also reveal the horrifying human cost behind its creation. Before we go any further, if you're finding this story compelling, I'd really appreciate it if you could hit that like button and subscribe to the channel. Your support helps us bring you more of these untold stories from history. And please drop a comment below letting me know what aspect of Second World War technology you'd like to explore next. The story of the V-1 actually begins long before that first devastating strike on London. It starts in the quiet corridors of British intelligence, where a small group of scientists and analysts were piecing together fragments of information about German secret weapons. At the center of this effort was Reginald Victor Jones, known simply as RV. Jones, a brilliant physicist who had been recruited into the Air Ministry's Intelligence Division. Jones had already made a name for himself by unraveling the mystery of German navigation beams during the Blitz. And now, he faced an even more challenging puzzle. The first concrete clue arrived in August 1943, when a Danish naval officer named Lieutenant Commander Hassiger Christiansen made a remarkable discovery on the island of Bornholm in the Baltic Sea. An unusual aircraft had crashed in a turnip field, and Christiansen immediately recognized its significance. The object was about 4 meters long, with stubby wings, and what appeared to be some sort of jet engine mounted on top. Most intriguingly, it had no cockpit, no place for a pilot. The warhead was a dummy made of concrete, suggesting this was a test model. Christiansen photographed the wreckage, made detailed sketches, and noted the number painted on its side, V-83, indicating this was the 83rd prototype of something the Germans were desperately trying to perfect. The Danish officer risked everything to get this information to British intelligence. Under German occupation, such actions could result in imprisonment or worse. But Christiansen understood the importance of what he had found. His photographs and sketches made their way through the resistance network and eventually landed on the desk of R.V. Jones in London. When Jones first examined the photographs, he was initially uncertain what he was looking at. The device could have been a larger version of the HS-293 glider bomb that the Luftwaffe was already using against Allied warships in the Mediterranean. But something about the design suggested this was different, something far more ambitious. The V in the designation could mean Versuchs, the German word for experimental or research. This was a weapon in development, and the British needed to know more. Jones and his team began cross-referencing the Bornholm discovery with other intelligence reports. They had received information from the Polish Home Army, the Armia Krajowa, whose agents had been monitoring unusual activity at Peenemünde, a remote research facility on the Baltic coast. The Polish resistance had recruited sources inside the German military, including an Austrian anti-fascist soldier named Roman Traeger, who was stationed on Euston Island near Peenemünde. Traeger provided detailed information about what he called flying torpedoes being tested at the facility. The Luxembourg resistance also contributed vital intelligence, as did agents embedded within the German military-industrial complex. Piece by piece, a picture began to emerge of a massive German effort to develop revolutionary weapons that could strike Britain without risking valuable pilots and aircraft. By the spring of 1943, the British government was taking the threat seriously enough that Winston Churchill ordered Operation Crossbow, a coordinated effort to identify and destroy these secret weapon production and launch sites. In August of that year, the Royal Air Force launched Operation Hydra, a massive bombing raid on Peenemünde that dropped thousands of tons of explosives on the research center. The raid killed several hundred German scientists and workers and set back the weapons program by several crucial months. But the Germans were not deterred. They simply dispersed their research and production to other locations, making them harder targets. Meanwhile, Allied reconnaissance aircraft began photographing strange construction sites appearing along the coast of occupied France. The structures had a distinctive shape that analysts quickly nicknamed ski sites, because the elongated buildings resembled skis lying on their sides. These were clearly launching facilities for something, but what exactly? The answer became terrifyingly clear on that June morning in 1944 when the first V-1s began falling on London. Within days of the initial attack, the bombardment intensified dramatically. At its peak, more than 100 of these flying bombs were being launched at Britain each day. The sound of their pulsing engines became a constant presence in the skies over southern England, and the silence, when those engines cut out, became the most feared sound of all. For the British scientists tasked with understanding this new weapon, the challenge was immense. They needed intact examples to study, but the V-1 was designed to explode on impact, leaving little more than twisted wreckage and devastation. What they needed was one that had failed to detonate, an unexploded flying bomb that they could carefully examine piece by piece. Their opportunity came when several V-1s crashed without exploding, their fuses failing or their fuel exhausted prematurely. One such device landed in a field outside London, and the call went out for the bomb disposal experts. The man who answered that call was Captain John Pilkington Hudson of the Royal Engineers, a specialist who had already earned the George Medal for his courageous work defusing conventional German bombs. Hudson was a remarkable individual, a horticultural scientist by training who had volunteered for bomb disposal work and had developed an almost intuitive understanding of German explosive devices. What Hudson faced with the V-1 was unlike anything he had encountered before. This was not a simple bomb dropped from an aircraft. This was a complete flying machine with multiple fusing systems, a massive fuel tank filled with gasoline, and nearly a ton of high explosives packed into its warhead. The operation to defuse it would take 9 agonizing days. Working alongside Hudson was a team of scientists and technicians, including Robert Hurst, a New Zealand-born chemist who would later help develop Britain's nuclear program. These men knew that one wrong move could result in an explosion that would vaporize them instantly. Making matters worse, the weather was warm, and as they worked, toxic fumes from the explosive began to affect them. They also had to contend with the psychological pressure of knowing that additional V-1s were being shot down by fighter aircraft in the area, crashing nearby with tremendous explosions. As Hudson and his team carefully cut away the outer casing of the V-1, they began to understand the ingenious yet terrifyingly simple design. The fuselage was constructed primarily from welded sheet steel, while the wings were made of plywood. This was not a precision weapon crafted from expensive material. It was deliberately designed to be cheap and expendable, built using the minimum resources necessary to deliver its deadly cargo. The heart of the machine was the Argus as 014 pulse jet engine, a revolutionary propulsion system that was startlingly simple in its construction. The engine consisted essentially of a tube with a set of spring-loaded flap valves at the front. Air entered through these valves, mixed with gasoline from the fuel tank, and was ignited by a single spark plug. The resulting explosion pushed the burnt gases out the back, creating thrust, and also slammed the valves shut. As the pressure inside the tube dropped, the valves reopened, fresh air rushed in, fuel was injected, and the cycle repeated itself 50 times per second. This rapid pulsing created the distinctive buzzing sound that earned the weapon its nickname of Buzz Bomb. The simplicity was remarkable. The engine had only one moving part, the valve assembly, and it could run on ordinary gasoline rather than the expensive aviation fuel required by conventional aircraft. But this simplicity came at a cost. The valves were only expected to last for about an hour of flight time, just long enough to deliver the bomb to its target. After that, they would fail. But since the weapon was designed to destroy itself anyway, this was considered acceptable. The guidance system was equally basic. A pair of gyroscopes maintained the V-1's attitude and heading, while a barometric device controlled its altitude. The direction was set by a magnetic compass that was pre-calibrated before launch. Range was determined by a small propeller on the nose of the bomb that turned in the airstream. This propeller was connected to a mechanical counter that ticked down with each rotation. When the counter reached zero, indicating the weapon had traveled the predetermined distance, a mechanism was triggered that put the V-1 into a dive, cut off the fuel supply, and armed the warhead fuses. This was why the engine sound stopped before impact. When the fuel was cut off, the pulsing ceased, and the weapon fell silent as it plunged toward its target. People learned to listen for that silence with dread, knowing that somewhere below, the bomb was about to strike. The warhead itself contained approximately 850 kilograms of high explosive, filled with a mixture called amatol. The fusing system was designed for maximum destructive effect, detonating the explosive on impact to create a devastating blast wave, rather than allowing the bomb to bury itself in the ground before exploding. As British scientists examined more V-1 components, they made several disturbing discoveries about the nature of this weapon. First, it was incredibly cost-effective compared to conventional bombing. Each V-1 cost the Germans roughly 5,000 Reichsmarks to produce, equivalent to about 2,000 American dollars at the time, which translates to roughly $27,000 in today's currency. Compare this to the cost of training a bomber crew, providing them with a sophisticated aircraft, fuel, ammunition, and supporting infrastructure. The V-1 could deliver the same destructive power as a bomber raid at a fraction of the cost and without risking a single German life. Second, the production process was designed for mass manufacture. The simple construction meant that skilled aircraft workers were not required. The sheet metal could be welded by relatively unskilled laborers, and the plywood wings could be assembled in basic workshops. Each V-1 took approximately 350 labor hours to produce, and at its peak, production reached thousands of units per month. But here is where the story takes its darkest turn, where the British scientists learned the truth about why the V-1 was designed the way it was and the horrifying human cost behind its creation. The main production facility for the V-1 was located deep underground in the Harz Mountains of central Germany, in a massive tunnel complex known as the Mittelwerk. This facility was not staffed by ordinary factory workers. It was operated by the SS using slave labor from the Mittelbau-Dora concentration camp. When British intelligence began receiving reports from resistance networks and escaped prisoners about conditions at Mittelbau-Dora, the scientists who had been so fascinated by the technical aspects of the V-1 were confronted with a moral horror beyond anything they had imagined. The prisoners at Mittelbau-Dora, drawn from concentration camps across Europe, were forced to work in conditions that can only be described as inhuman. In the early phases of the operation, beginning in late 1943, Prisoners were not even allowed to see daylight. They lived inside the cold, damp tunnels, sleeping on wooden bunks stacked 3 high in passages carved from raw rock. The air was thick with dust from the constant drilling and blasting as the tunnel system was expanded. There was no adequate ventilation, no sanitation, and barely any food. Prisoners worked 14-hour shifts, 7 days a week, sustained by watery soup and small rations of bread. The mortality rate at Mittelbau-Dora was among the highest of any concentration camp in the German system. Of the roughly 60,000 prisoners who passed through the camp and its subcamps, an estimated 20,000 perished. They died from exhaustion, from starvation, from disease, from the toxic dust that filled their lungs. They died from cave-ins when tunnels collapsed. They died from beatings by SS guards who showed no mercy. And they died from deliberate acts of cruelty, including mass hangings for those suspected of sabotage. Over 200 prisoners were publicly hanged for attempting to sabotage the production process, their bodies left hanging from cranes and machinery as a warning to others. Yet despite this terror, the resistance continued. Prisoners found small ways to delay production, to introduce subtle defects into the weapons, to fight back against their oppressors even when they knew the penalty was their lives. When the British scientists examined the construction of the V-1s, they could now see the evidence of this slave labor in the very materials. The rough welds, the simple construction, the use of basic materials, all of this was designed not just for efficiency, but because the workforce consisted of starving, exhausted prisoners who were worked to the point of collapse. The Germans had calculated that it was cheaper to work prisoners until they died and replace them with new arrivals than to provide adequate food, shelter, and working conditions. This was the true horror behind the V-1. It was not merely a weapon of terror against the people of London. It was itself the product of terror built by human beings who were treated as less than human, constructed in tunnels that became mass graves for thousands. The simple, expendable design of the V-1 suddenly took on a new meaning. The Germans needed a weapon that required minimal skilled labor precisely because they had none. They needed a weapon that could be built quickly by workers who were barely alive. The efficiency that had seemed so technically clever was actually the efficiency of cruelty, the cold calculation that human lives, both the prisoners who built the weapons and the civilians who would be struck by them, were simply resources to be consumed in the pursuit of vengeance. Meanwhile, as these revelations filtered back to British intelligence, the V-1 attacks on London continued with devastating effect. By the end of summer 1944, thousands of flying bombs had struck the city. The attacks were random and relentless, hitting residential neighborhoods, shops, churches, and schools. Unlike the Blitz of 1940-41, where German bombers typically attacked at night, the V-1s came at all hours. There was no pattern, no schedule, just the constant threat that at any moment, anywhere in the city, the buzzing could stop and a bomb could fall. The psychological effect was tremendous. People reported that the V-1 campaign was in some ways worse than the Blitz. During the Blitz, you could hear the bombers coming, you could take shelter, and when the all clear sounded, you knew the danger had passed. With the V-1s, there was no all clear. They came singly or in small groups, day and night, and there was no way to know where the next one would fall. Over 1.5 million people evacuated London during the summer of 1944, fleeing to the countryside to escape the bombardment. Those who remained lived in a state of constant anxiety. The sound of the V-1 engine became so recognizable that people would freeze in their tracks when they heard it, listening for that terrible moment when the buzzing stopped. In response to this threat, the British mobilized an impressive array of countermeasures. Operation Diver was the code name for the defense plan, and it involved multiple layers of protection. The first line of defense was the Royal Air Force fighter squadrons, whose pilots attempted to intercept the V-1s over the English Channel and the countryside before they could reach London. This was incredibly dangerous work. The V-1 flew at speeds approaching 400 miles per hour, faster than most British fighters could achieve in level flight. Pilots had to dive on the bombs from above to build up enough speed to catch them. Even then, shooting down a V-1 was hazardous. If the bomb exploded, the pursuing aircraft could be destroyed by the blast. Some pilots developed a technique called tipping, where they would fly alongside the V-1 and use their wing to flip the bomb's wing, disrupting the gyroscope and causing the weapon to crash. This required extraordinary flying skill and steady nerves. The second line of defense was anti-aircraft artillery, which was positioned along the coast and in a belt across Kent. Initially, the guns were placed inland, but it was soon realized that shooting down V-1s over populated areas was counterproductive, as the bombs would still explode where they fell. The gun batteries were therefore moved to the coast, where they could intercept the weapons over open water or farmland. New technology aided this effort. Radar-guided guns using the SCR-584 system could track the fast-moving targets and predict their flight paths, making the gunners far more effective. By August 1944, the combination of improved guns and proximity fuses, which detonated shells when they passed near the target rather than requiring a direct hit, dramatically increased the success rate. The third line of defense was barrage balloons, which flew over London trailing steel cables. The idea was that the V-1s would hit these cables and be brought down before reaching their targets. This method had some success, but was limited in effectiveness. Perhaps the most clever British countermeasure was not physical, but informational. The Germans needed to know where their V-1s were landing in order to adjust their aim. They relied on agents in Britain to report the impact locations. What they did not know was that every single German agent in Britain had been captured and turned by MI5 as part of the double-cross system. These double agents fed false information back to Germany, reporting that the V-1s were overshooting their targets and landing north of London. The Germans, believing these reports, adjusted their aim accordingly, which caused the bombs to fall short, hitting the less densely populated southern suburbs rather than central London. It was a morally difficult decision for British authorities, as they were essentially deciding that some areas should be hit to save others. But the calculation was that overall casualties would be reduced, and the double agents continued their deception throughout the campaign. Despite all these countermeasures, thousands of V-1s still got through. The attacks continued until October 1944, when Allied ground forces advancing through France overran the last launch sites within range of Britain. But the terror was not over. The Germans had developed air-launched V-1s, carried aloft by modified Heinkel He-111 bombers that would release them over the North Sea. These attacks continued sporadically through the winter of 1944 and into 1945. Even more devastating was the arrival of the V-2 rocket, the second of Hitler's vengeance weapons, which began striking London in September 1944. The V-2 traveled at supersonic speed, giving no warning before impact. There was no defense against it, no time to take cover, no buzz to warn of its approach. One moment there was peace, the next moment devastation. But throughout all of this, British scientists continued their work, analyzing captured V-1s and developing countermeasures. The information they gathered was shared with American allies, who began their own program to reverse engineer the weapon. Within weeks of receiving V-1 components from Britain, American engineers at Wright Field had produced a working copy of the pulse jet engine. By September 1944, the first American version of the V-1, called the JB-2, had been assembled at Republic Aviation. The United States planned to produce tens of thousands of these weapons for potential use in the planned invasion of Japan, though the war ended before they were deployed. The technical legacy of the V-1 extended far beyond the Second World War. It was the world's first operational cruise missile, the progenitor of weapons that would become central to military arsenals for decades to come. The concept of a cheap, expendable, guided weapon that could strike targets at long range without risking human operators would be refined and improved, eventually leading to the Tomahawk missiles and other precision weapons used in modern warfare. But for the scientists who first examined the V-1, who took apart its components and traced its origins, the weapon represented something more complex than simple technological achievement. It was a reminder of the dual nature of human ingenuity, our ability to create remarkable machines, and our capacity to use those creations for destruction and suffering. The V-1 campaign against Britain resulted in approximately 6,200 lives lost in the London area alone, with nearly 18,000 more seriously injured. But this toll must be weighed against the estimated 20,000 prisoners who perished at Middlebow-Dora and its subcamps, many of them building the very weapons that would rain down on British cities. More people died producing the vengeance weapons than were ever harmed by them. When American forces liberated Middlebow-Dora in April 1945, they found scenes of unimaginable horror. The SS had evacuated most prisoners on forced death marches, leaving behind only the sick and dying. The tunnels were littered with bodies, the evidence of systematic cruelty impossible to ignore. After the war, there was a reckoning of sorts. Some SS officers who had run the camp were tried and convicted of war crimes. But many of the scientists and engineers who had overseen the weapon production, including some who had visited the tunnels and witnessed the conditions, were never prosecuted. Some were recruited by the United States and Soviet Union in programs like Operation Paperclip, their expertise considered too valuable to punish. Werner von Braun, the technical director of the V-2 program, who had visited the Mittelwerk facility multiple times, went on to become one of the leading figures in American space exploration, helping to develop the rockets that would carry astronauts to the moon. His wartime past was largely overlooked in the rush to secure scientific advantage in the Cold War. For the British scientists who had examined the V-1, who had traced its origins and discovered the truth about its production, the experience left lasting impressions. R.V. Jones went on to write extensively about his wartime intelligence work, emphasizing the importance of scientific expertise in military matters. John Pilkington Hudson returned to his first love of horticulture after the war, eventually making important contributions to agricultural science, though he rarely spoke of his bomb disposal work. The V-1 itself passed into history, a footnote in the larger story of the Second World War. But the lessons it embodied remain relevant. The weapon demonstrated that terror can be mass-produced, that technology can enable new forms of warfare, and that the true cost of such weapons often falls on those least able to resist, the prisoners who built them and the civilians who suffered their impact. Today, surviving V-1s are displayed in museums around the world, including the Imperial War Museum in London, where visitors can see the simple steel and plywood construction up close. The distinctive shape, the stubby wings, the pulse jet engine mounted above the fuselage, all of it appears almost primitive compared to modern weapons. It is hard to imagine that this crude device once terrorized millions and represented the cutting edge of military technology. But perhaps that simplicity is what makes the V-1 so important to remember. It was not a sophisticated weapon that required great resources to produce. It was deliberately cheap, deliberately expendable, designed to be built by slave labor and launched in massive numbers. The V-1 showed that terror could be industrialized, that suffering could be scaled up, that warfare could reach into cities and strike randomly and repeatedly without warning. The British scientists who examined those first V-1 components in the summer of 1944 could not have known all of this immediately. They started with a technical puzzle, trying to understand how the weapon worked and how it could be defeated. But as their investigation deepened, as intelligence reports came in about the production facilities and the conditions there, they learned that they were not just studying a weapon. They were confronting the darkest aspects of human nature, the willingness to exploit and destroy lives in pursuit of vengeance. That is perhaps the most important lesson from the V-1 story. Technology is never neutral. Behind every weapon, every military system, every instrument of destruction, there are human choices, human costs, and human consequences. The British scientists learned that lesson the hard way in the summer of 1944 as buzz bombs fell on London and the truth about their creation emerged from the shadows of Nazi Germany. As we remember the V-1 flying bomb, we should remember not just the technical achievement it represented, but the full scope of its story, the terror it inflicted, the lives it claimed, and the suffering that went into its creation. Only by understanding that complete picture can we truly appreciate what those British scientists learned when they examined those components, and why that knowledge carried such weight. The buzzing has long since stopped over London. The launch sites in France are overgrown ruins. The tunnels at Mittelbau-Dora stand as memorials to those who perished there. But the story of the V-1 continues to resonate, a reminder of what humans are capable of, both in our ingenuity and our cruelty. Thank you for watching this exploration of one of the Second World War's most significant and troubling weapons. If you found this story compelling, please consider subscribing to the channel and sharing this video with others who might appreciate it. Your support makes it possible for us to continue bringing these important historical stories to life. And please take a moment to leave a comment below. I would love to hear your thoughts on the V-1 campaign, the moral complexities of wartime technology, or any other aspects of this history that struck you. What other stories from military history would you like to see explored? Until next time, remember that history is not just about dates and battles. It is about the human experiences behind those events, the choices people made, and the consequences that followed. The story of the V-1 flying bomb is ultimately a human story, one of terror and resistance, of scientific achievement and moral horror, of a weapon that revealed as much about its creators as it did about the nature of modern warfare. The buzz bombs may have fallen silent 75 years ago, but their echoes still resound today, reminding us of the importance of understanding our past and the responsibilities that come with technological power. Those British scientists who first examined the V-1 components learned lessons that remain vital, that weapons are never just machines, that costs are never just financial, and that the pursuit of military advantage can exact a price in human suffering that defies calculation. May we never forget those lessons, and may we honor both the victims of the V-1 attacks and the prisoners who were forced to build them by remembering their stories truthfully and completely.